We're now going to take a look at part 2 of case study ex3, and this is going to show off another slew of operators from Flux, such as flatMap and generate and so on. And we'll also do things like reduce and collect. And we'll use the parallel thread pool to create, reduce, multiply, and display BigFraction objects asynchronously in a parallel thread pool. And we're also going to show off, again, some mono operators too, although they're not as much of a focus here. So let's take a look at the ex3 project in the reactive Flux folder in my live lessons GitHub repository. So here we are back in the ex3 project. There's the ex3 entry point. And this time we're going to take a look at the test fraction multiplications 1, test fraction multiplications 2, and test fractions multiplications 3 methods under test, which are all registered with the async task barrier, which runs all the tests asynchronously and then waits until we're done. And I forgot to show you the output, so let's look at the output from last time. So here's the output from running the test fraction exception methods. As you can see here, we logged the first 3 of these elements, and then we got an exception, which was divide by 0. And because the first one just stopped at that point, we're done. In the second case, we also did the same thing. We went ahead and caught the exception, but we handled things in different ways. So we didn't stop. This stopped, whereas this continued on, and then it summed the results. So we ended up printing the sum of these results. And then in the final case for test fraction exception 3, once again, we had an exception occur when the denominator was 0. So you see the exception there. However, this time we did the on-error resume operation, which just returned a 0 in that case. And you can see here we get the 0. So we multiplied 4.5 by 0, which of course yields 0. And because of that, we went ahead and, of course, ignored the 0. And we went ahead and took all the results and summed them up. So those were the 3 different results from the first run of part 1 of case study ex2. So now let's go ahead and take a look at the Flux EX, and we're going to start by looking here at test fraction multiplications 1. And you can see here what we're going to do. This is kind of fun. We're going to use the Flux generate factory method, which will, in this case, generate an infinite stream of random unreduced big fractions by saying sync.next. Sync is the synchronous sync parameter that's passed here. And we're going to generate an infinite stream of this. However, since we don't want this program to run infinitely, we're going to stop after S max fractions of these things have been emitted. We're then going to go ahead and use the flatMap concurrency idiom in order to take each of these unreduced big fractions and reduce and multiply them. And you can see what we're doing. We're calling a helper method that takes in the unreduced fraction, the scheduler's parallel thread pool, and the string buffer. If you go look at reduce and multiply fraction, you can see what it does is it takes the unreduced fraction that was passed in as a parameter, emits it from a mono, subscribes the contents of the processing to run in the scheduler parameter, which, as we saw, was the parallel scheduler. We then log the results using doOnNext. This is now working on a mono. And then we use the mono map operation to take the value and multiply it by some big fraction. All of this takes place in the parallel scheduler that was passed as a parameter here. So the upshot of all this stuff is that each of the big fractions here that we generated by using the generate method will be reduced and multiplied in parallel in the parallel scheduler pool. And when we're all done with all that computation, the last thread that comes through will be used to collect the results into a mono to a list of big fractions. And then, of course, we're going to use the flatMap operation on that mono in order to sort and print the list. Same logic we had before. This will quick sort the list and heap sort the list in parallel, once again using the parallel scheduler thread pool. And then we take whichever one finished first. Excuse me. We take whichever one finished first, and we display the results. So that's how this is going to work, very much like we looked at in part 1. Let's now go ahead and take a look at test fraction multiplications 2. This is going to do things a little bit differently. It's going to make an array of big fractions that are reduced. They start out reduced. And then we're going to convert that big fraction array into a flux. We're going to apply the flatMap concurrency idiom. This time, we're just going to multiply each of these fractions by the constant. If you take a look at multiply fraction, you can see that what multiply fraction does is it takes the big fraction and multiplies it by some constant, does that in the parallel scheduler, and logs the results. We then reduce everything using the reduce operator, adding them all together. And then, if all goes well, we display the results of this stuff and return back to the async task bearer a monitor void saying this particular processing is finished. And the third and final of these methods under test will once again use the generate method to generate a gaggle of big unreduced fractions, take up to S max fractions of them, use flatMap. And what we're going to do here is really fun. So this is going to reduce and multiply each fraction. Remember, we took a look at that before. So we're going to have reduce and multiply fraction here. And that will end up giving us back a stream of reduced and multiplied big fractions. And now we're going to show off a different operator called collectMultiMap. So collectMultiMap is a variant of collect. And what it's going to do is it's going to collect the big fractions into a multi-map. And the map's key will have the numerator, and the map's value will be the denominator. So key and value pairs will be numerator and denominator. And we're going to use a hash map to store the results. And then we're going to go ahead and print the map. So this is, I'm just showing you off yet another cool operator. I should actually add that to my earlier discussion about cool combining operators, collectMultiMap. So you can collect things into a map as opposed to collect things into a list or a set or whatnot. And then down here, the print map operation is going to walk through the contents of this map, and it'll take the numerators and denominators, and for each denominator, it's going to go ahead and print out the results that we have here. And then we print the results here using this particular consumer. So super cool illustration of yet another combining operator that's supported by Project Reactor called collectMultiMap. Okay, and I think that is basically it. So that's the end of case study ex3.